All right, here we are, and we're taking a look at bridge circuits this time. So let's talk first about how a bridge circuit is constructed, or this particular type of bridge circuit. So we have two series circuits connected in parallel, or two voltage dividers connected in parallel would be another good description. And since we just learned about voltage dividers, I don't think it's difficult to see why we would call those two voltage dividers connected in parallel, because you can see the two tap-off points there in our circuit. All right. So the purpose of a bridge circuit, though, is to compare a known value to an unknown value. So our known side is R1 and R2, so that would be the voltage at test point 1, and our unknown side is Rx and Rs, which is the voltage at test point 2. What we're going to look at right now is how we get the voltages at both test point 1 and test point 2 and how we compare those voltages. All right, so we start with the voltage at test point 1, and I'm going to start with the currents through our branches. Those are real easy calculations. I take my 30 volts applied to the branch and divide it by the 15K ohms that are in the branch, and I get 2 milliamps. Now it just so happens that branch number 2 also has 15K ohms, 7K and 8K, so I take my 30 divided by 15K and I get the same 2 milliamps for the second branch. Now that I have that, I need to look at what I am reading across in order to get my voltage drop. So if I'm looking for the voltage at test point 1, I'm going to put my black lead at ground and my red lead at test point 1. Now the only thing in between those 2 points is R2. So we are actually reading the voltage of R2 when we read the voltage at test point 1. So in that case, we will take the ohmic value, of course, of R2, which is 5,000 ohms, and multiply it by the current of the branch, which is 2 milliamps, and we get a voltage of 10 volts. So test point 1 is 10 volts. We do the same thing on the other side of our circuit, and we know that if we put our red lead on test point 2 and our black lead on ground, the only thing in between those 2 points is Rs. So the voltage at test point 2 is the voltage on Rs. We're going to use the same process. We're going to take the current in the branch and multiply it by the ohmic value of Rs, which is 8,000 ohms, multiplied by 2 milliamps, and we get a voltage drop of 16 volts at test point 2. So we have our voltage at test point 1 of 10 volts, and we have our voltage of test point 2 of 16 volts. Now, in order to measure, we would reference in our known side. So we would put our black lead at test point 1, and we would put our red lead out on our unknown. So for this reason, you are going to take, as we always do, red minus black. So if you're taking red minus black, it's going to be test point 2 minus test point 1, which takes 16 minus 10. You end up with a voltage difference of 6 volts. Now, if the known side happened to be a greater value than the unknown side, you would end up with a negative voltage. These types of bridge circuits are frequently used in things like the home AC units, where you can set a particular temperature and then you have a sensing device, a resistor that is sensing the room temperature, and then those two values together compared to your known value are turning your AC or your heat on or off. All right, so we're going to go to the next slide and look at how to solve for an unknown in a balanced bridge circuit. Now, balanced simply means that the difference between test point 1 and test point 2 is 0. So if both test point 1 and test point 2 had the same voltage, then if I took one minus the other, I would get 0. And that's what we mean when we say balanced. All right, so solving for an unknown in a balanced bridge circuit. You can see here that Rx happens to be our unknown. What we do is we cross multiply, and this works because test point 1 and test point 2 are the same value. So what we do, if you're not familiar with cross multiplication, you fill in the numbers that you have and then your unknown as well. So I have 10k over 5k, which is r1 over r2, and then I have rx, which we don't know the value to, over rs, which is 8k. So when you cross multiply, you're going to take the ones that are cross from each other, in this case 10k, or I should say diagonal to each other, in this case 10k and 8k, and multiply them together. So I multiply those two and I get 80 meg. Then I'm going to take that value and divide it by 5k, which is the value that is diagonal to my unknown. And so I take 80 meg and I divided it by 5k and I get 16k ohms. So that is the value of Rx, 16k ohms. And that is how you solve for an unknown in a balanced bridge circuit using cross multiplication. All right, everybody go out and have fun doing bridge circuits.